It is difficult to know what is in anyone's mind. The nature of existence is subjective. We assume we understand each other, but we never really know. But our relationship with technology, up until this exact moment in the human story, has been different. It has been a relationship where we, or at least the technicians among us, knew exactly how things were made. If a clock stopped working, we could take it apart, see the broken gear, and put it back together. If a computer did something unexpected, we could debug it.
But that era is over. We are leaving that comfortable, predictable relationship behind. We are entering a world where you can ask the machine the same question 100 times, and it will give you 100 different answers. If you are asking for a poem, that's fine. But if you are asking for a medical diagnosis or a financial projection, let's just say things could get interesting.
With AI, you aren't just using software. You are holding a tiger by the tail. And the terrifying part isn't that the tiger might bite you. It's that the tiger is invisible. The mechanism by which you get results is opaque and impenetrable. Moreover, the systems that create the results we get from AI are fleeting. They undergo calculations that exist in the moment and vanish when the results have been achieved.
We are essentially building a world on invisible, disposable software that no one is testing, no one is watching, and no one understands.
Hello, everyone, and welcome back to the Verlicity AI podcast. I'm Cristian Worthington.
And I'm Sandra Giffen.
Sandra, we are back. It's the beginning of our second season of Verlicity AI, and we're getting very close to announcing our new app that we've been developing. The excitement is building.
Yes, and so is the fatigue. The past month, we've been testing our new app, and it's been grueling.
It has. So we're starting with the topic that has been keeping me up at night, literally. As our listeners know, we are deep in the development of our own AI application. And the deeper we get, the more I realize that the ground beneath our feet, the fundamental nature of software, has shifted.
We used to live in a mechanistic era. If I wrote a line of code, print hello world, it would print hello world every single time, 1,000,000 times in a row. It was deterministic.
And because it was deterministic, we could trust it. But our existence with AI propels us toward a world of uncertainty. We are moving from logic to probabilistic reasoning. And that sounds academic, but let's look at the reality. We can ask the same question 100 times, and the AI will give us 100 answers.
And this is the core friction right now. If you are asking a general knowledge question, who was the fourth president? Or, write me a haiku about autumn. The form of the answer is irrelevant as long as the facts are roughly right. If the haiku is different every time, that's actually a feature, not a bug. It feels creative.
But what happens when precision is required? What happens when that system is calculating a dosage or the loading factors for a bridge? When AI is combined with systems upon which critical decisions are made, such as financial decisions or health matters, our tolerance for error is extremely low. Actually, it should be zero. And our need for accountability is extremely high.
But it can't be zero anymore. That's the hard truth we have to swallow. If you use a stochastic system, a system based on randomness, you are accepting that zero error is mathematically impossible.
And that brings us to the tiger. When you add these probabilities together, when you chain them, you find yourself holding a tiger by the tail. And right now, the entire tech industry is acting like that tiger is a house cat.
Let's talk about the dirty work of this revolution. We hear a lot about the magic of AI. It's impressive. A lot of press is given to miraculous coding agents that can build any system we want. Just type a prompt and get an app.
But very little is said about testing, and there is a reason for that. Testing is boring. It is drudgery. It is the unsexy plumbing of the software world. But here's the rub. When we want to know what someone is thinking, we need to listen to them talk. We need to ask the person questions. When we want to know what an AI is thinking, the process is essentially the same. Testing is the only way we can peer into the mind of the AI and know that it is thinking what we want it to think.
I'm reminded of the old phrase, a penny for your thoughts. But in the AI world, it's not a penny. It costs money, lots of money, to test a complex system and validate that its thinking is aligned with your wishes. It costs your time. It costs a lot of AI tokens, and it costs even more if you fail to catch a critical flaw.
Let's break down why it's so expensive. In the old days, acceptance testing meant checking if the buttons worked. Does the save button save the file? Yes or no. Binary. But now, we are testing vibes. We are testing reasoning. We are testing a black box that might operate perfectly 100 times and decide to hallucinate a fact only on the first Tuesday of every month.
And we are seeing this with our own app development. Acceptance testing old-school software was never a picnic, but testing a system that relies heavily on AI is next level. Most people using AI today use AI chatbots, where the interactions operate in steps. The user enters a query and the AI generates an answer. At each stage in a conversation, the user gets to evaluate the answer and decide whether it makes sense.
In our application, the user clicks a button and a workflow occurs that can make hundreds of API calls to the AI without the user even knowing what's going on.
The whole process was written by an AI, is being executed by an AI, and a human is not in the loop until the very end.
Let's say you have an AI agent that does research. Step 1, search Google. Step 2, summarize the results. Step 3, write an email. That's 3 steps. If each step is 99% accurate, which is incredibly high for an AI, you still have a cumulative error rate. But a workflow with 100 API calls has 100 opportunities to go wrong.
And the math on that is brutal. Even at 99% accuracy, after 100 steps, your success rate drops to about 36%. You're failing 2/3 of the time. And the worst part, you don't know where it failed, why it failed, or in some cases, if it failed. And unless you take extreme measures to log a lot of data during the process, you probably have no way to figure out how it can be fixed.
Exactly. Did it fail at the search, the summary, the writing? To catch that, you need to log and test every single step. You have to pay the penny for every single thought the AI has. And that is the hidden tax of the AI revolution that no startup deck is talking about.
I want to pivot to something even more invisible. We are talking about testing systems, apps we build and sell. But there is a new phenomenon happening that I think is even more radical. It's the rise of disposable software.
Ah, yes. This is a concept that blows people's minds when they first grasp it. Software is being dynamically created by AI and used in many applications.
Explain how that works for the non-technical listener.
Okay, so you go to ChatGPT or Gemini and say, analyze this spreadsheet and tell me the average sales for March. The AI doesn't think about the math in its head. It literally writes a small computer program, a Python script, in the background. It runs that script, gets the answer, shows you the answer, and then deletes the script.
It's single-use code. It's disposable, like a paper plate at a picnic. Imagine The majority of the software that will be run in the not-too-distant future will be written on the fly, used once, and discarded.
Think about the implications of that. No acceptance testing, no debugging, no accountability. This isn't a hypothesis or a wild prediction of an unlikely future. It's happening now. Every day, millions of little software programs are born, executed, and die in milliseconds.
And if that script has a bug,
you'll never know. There is no GitHub repo to check. There is no version history. The error just happens, affects your decision, and vanishes. If you log into a chatbot, ask a question that requires the chatbot to write a Python program, and it produces a wrong result. There is no way for anyone to record or effectively report a bug, other than clicking thumbs down.
And thumbs down is not a bug report, it's just sentiment. It doesn't tell the engineers why it failed, so we are creating a layer of disposable software that you call background radiation of the new frontier in software.
Yes, it's not a stretch to assume that errors are happening at a colossal scale, and they are just becoming part of the background radiation of life. We are acclimating to a world where truth is just mostly true. We are accepting a level of fuzziness in our digital infrastructure that would have been unacceptable 3 years ago.
Let's talk about the scale, because I think people underestimate the volume we are talking about. We used to be impressed by the App Store.
Right. The days when your iPhone or Android could run nearly 2 million apps will seem quaint. 2 million seems like a lot. But we are in a world in which there are millions of mini-apps created, executed, and disposed of every day, never to be used again, never tested.
And vibe coding is taking this to a level of complexity that far exceeds a one-line Python script used to answer a question in a chatbot interaction. Because the barrier to entry is effectively zero for vibe coding, the number of more complex apps is exploding, and because most of these apps are used privately by users who develop systems to solve problems in their personal life or business, the scale of this phenomenon is nearly impossible to measure. Imagine, if I need an app to manage the inventory of my specific refrigerator, I can have the AI build it for me in 30 seconds. I use it for a week, then I delete it. Did it work properly? Did it cause harm? No one will know.
Systems that were once too complicated to build are suddenly easy to build. Problems that were once too uncommon to automate are suddenly economical to automate. The opportunity space for software has grown by orders of magnitude.
This is the long tail of software. We are moving from mass-produced software, Microsoft Word, Excel, to bespoke, artisan, disposable software. But here is the catch. Microsoft has thousands of testers. They have QA departments. My refrigerator app has me.
And you aren't a tester. You're just a person trying to find the milk in your fridge. So, as AI coding agents invade every aspect of life, the potential for error will multiply at a speed we've never encountered. And virtually nothing is being built these days without AI. Even the professional software is being written by AI co-pilots. The sheer volume of software is going to explode, as is its complexity.
So, we have painted a picture of a world drowning in invisible, untested, disposable code. A world of background radiation errors. This is a crisis of verification. If we can't take the clock apart, how do we know what time it is?
That is the question of the decade. I've been reading about the replicability crisis in science. You know, where scientists can't reproduce the results of famous experiments.
Right, because the conditions were unique, or the data was massaged.
Well, with AI, we are creating a replicability crisis for everything. If I ask the AI for an answer today, and you ask it tomorrow, we get different answers. The truth is not stable. So how do we solve this? I think we need to introduce a new concept for our listeners: golden sets.
Golden sets?
In the AI engineering world, since we can't look at the code and find the bug, we have to treat the AI like a student taking a test. We create a golden set of questions where we know the answer. What is 2 plus 2? Who is the CEO of Apple? And we run the AI against this golden set every single day.
So we are constantly auditing it.
Yes, we are probing the mind of the AI. Are you still sane today? Did the latest update break your math skills? This is the only way to peer into the mind effectively. We have to shift from code review, looking at the lines, to behavioral review, looking at the actions.
This feels very human. It's like hiring an employee. I don't know what neurons are firing in your brain, Chris. I can't debug your brain, but I can judge you on your output. I can judge you on your track record.
Exactly. We are moving from engineering management to performance management. We have to manage our software the way we manage people. We don't trust people blindly. We verify. We check their work. We have performance reviews.
So the solution to the tiger by the tail isn't to try to chain the tiger. It's to watch the tiger like a hawk. It brings us back to the accountability anchor concept we touched on in the Christmas episode. If the software is disposable and unaccountable, the human using it must be hyper-accountable.
So let's get practical. We have listeners who are business leaders, developers, or just regular people using these tools. If you are living in a world of background radiation errors, how do you protect yourself?
The first rule is high stakes equals zero trust. If you are using AI to write a poem, trust it. Have fun. If you are using AI to write a legal contract, or a medical protocol, or a structural engineering report, you assume it is wrong.
Trust but verify is too generous. It should be distrust and verify. You need to adopt probabilistic thinking. Don't ask, is this answer true? Ask, how confident am I in this answer? If the AI gives you a citation, check the link. If the AI writes code for you, run it in a sandbox, not on your production server.
And for the developers listening, the people building these agents, you have to embrace the drudgery. You have to pay the penny for the thoughts. You need to build those golden sets. You need automated testing that runs 100 times, not once.
Right. Because of the stochastic nature, passing the test once means nothing. You have to pass the test 100 times to know your probability of failure. If it fails one time out of 100, that's a 1% error rate. In a system with 100 steps, a 1% error rate is catastrophic.
It's a different discipline. We are moving from being architects of logic to statisticians of behavior. But we have to be realistic here. We just told our listeners to verify everything, to check every citation, to look for the hallucinations. But if we are moving to a world with millions of disposable apps and billions of transactions, humans can't check all of that. We don't have enough hours in the day.
You're right. We can't scale humans, so we have to fight fire with fire. We will have to use AI to police the AI.
This sounds recursive. So you're saying the problem is the solution?
It is. And to explain how this works, I want to take us back to the 1980s. I want to talk about the space shuttle.
Okay, I love a good NASA analogy.
The space shuttle was a fly-by-wire vehicle. No human could physically move the flaps fast enough to keep it from crashing. It needed the computer. But computers crash. They have bugs. And cosmic rays can flip bits in their memory. So NASA didn't just put one computer on board. They put 5.
5?
Yes. 4 of them ran the exact same software, processing the exact same data at the exact same time, and every millisecond, they voted. If computer A, B, and C said, turn left, but computer D said turn right. The system ignored computer D. It assumed D was hallucinating.
It's consensus logic. The truth is what the majority agrees on.
Exactly. And we are now doing this with AI. In our own development shop, we don't just ask one model for the answer. We might ask Gemini to write the code. Then we ask GPT-4 to review the code. Then we ask Claude to write a test for the code.
We are creating a digital council of elders. If Gemini 3 and GPT-4 agree, we proceed. If they disagree, we flag it for a human.
We are using the stochastic nature of AI against itself. Since they all make errors randomly, the odds of them making the exact same error at the exact same time are astronomically low. So redundancy creates reliability.
But there is another technique we use, which I think is even more clever. It's the counterfactual.
This is critical. AI models are sycophants. They are people pleasers. If you ask an AI, does this business plan look good? It is biased to say yes because it wants to be helpful. It wants to complete the pattern you started.
It's a yes man. And yes men are dangerous in business.
So you have to force the AI to wear a different hat. You don't ask, is this right? You ask a second AI agent. Imagine you are a skeptical investor. Deeply analyze this plan and tell me 3 reasons why it will fail.
You force it to take the opposing view.
Precisely. You explicitly program a red team AI whose only job is to try to break the logic of the blue team AI. You make them debate. And then, and only then, do you look at the transcript of that debate to find the truth.
So, the future of safe software isn't just user versus machine. It's machine versus machine, with the human as the judge.
That is the only way to handle the scale. We build the arena, we set the rules, and we let the AIs test each other until the truth emerges. So as we wrap up, I want to return to that image of the invisible tiger. The software explosion is incredible. It's democratizing creation. It's allowing us to build things we never dreamed of, but it is also filling our world with a kind of digital fog.
And our job, as conscious data curators, as we've called ourselves before, is to be the lighthouse in that fog. We cannot be passive consumers of AI output. We have to be active, skeptical, rigorous critics.
We have to peer into the mind of the AI. We have to be the ones who ask the hard questions. Because if we don't, we are just letting the background radiation accumulate until it becomes toxic.
The future belongs to the curious, yes, but it also belongs to the careful. The builders who test, the users who verify, the people who refuse to let the drudgery stop them from finding the truth.
That is the challenge for this year. Build fast. Vibe code. Use the disposable software. But never, ever stop watching the tiger.
Thank you for listening. And remember to share this episode with a friend and follow us on YouTube or any of the podcast apps so you don't miss a thing.
I'm Cristian Worthington.
And I'm Sandra Giffen. Stay sharp. Don't forget to test your AI from time to time, and we'll see you next time on the Verlicity AI Podcast.